Hi, I am Dr JMR, JMR Chemistry. Today, I would like to explain about reactivity series. I uploaded nearly 270 videos. Please like, share and subscribe to my channel, that is JMR Chemistry. Today I am going to explain about reactivity series. What is reactivity series? Reactivity series is an arrangement of metals. The systematic arrangement, how highest to lowest reactivity. Highest to lowest reactivity. So a series of metals arranged in decreasing order of reactivity. So means most reactive metals you have to place at the top of the series and a low reactivity series at the bottom of the reactivity. So if you will go through it is also known as reactivity series or activity series, both are same. Suppose if you will go through that, so here potassium, sodium, calcium, magnesium, aluminum. This is non-metal, but I incorporated because where it stands. So that is why here zinc, iron, lead, and this is also non-metal. I will explain regarding hydrogen. Next copper, mercury, silver, gold, and finally platinum also. So here based on this hydrogen, which one? Based on this hydrogen, so we classified the metals. So here these metals are highly reactive, so and these metals are somewhat low reactive when compared to above metals. So here how to what remember these metals, that is, please stop calling me a cute zebra. I like her calling me smart goat. Means what? P means potassium, S means sodium, calling C means calcium, M means magnesium, A means aluminium, C means carbon, Z means zinc, here I means iron, L means lead, H means hydrogen, C means copper, M means mercury, S means silver, G means gold, and finally least active metal, that is platinum. So you have to remember like this. Please stop calling me a cute zebra. I like her calling me smart girl. Once again, please stop calling me a cute zebra. I like her calling me smart goat. So you have to remember like that. So here, please go to the 3-4 times. Automatically you will get this reactivity series. So these reactivity series are very important, because here based on this I am going to explain how it is important. So here you take potassium and what do you call sodium and calcium. They are highly reactive in nature. So magnesium, aluminum, zinc, iron, tin and lead, these are somewhat less reactive metals. So here based on this hydrogen, they classified into two parts. What are they? So these metals liberate hydrogen gas when it is react with water. When it is react with water, they liberate water hydrogen gas with the formation of the respective hydroxide, and hydrogen gas is liberated. You take this one sodium hydroxide, what you calcium hydroxide, so to form the respective hydroxides up to this part, and here they react with cold water only to form the respective hydroxide with the liberation of hydrogen gas. Then what about next? They react with water, but hot water. So they react with hot water to form the respective what you call oxide. Suppose you take zinc oxide or magnesium oxide, aluminum oxide. So zinc oxide, ferric oxide, then stannous and lead with the liberation of hydrogen gas. But here what happened? For these metals from magnesium to aluminum and here lead, they required some heat. So you have to heat these metals, and here what happened, you have to pass what steam is passed because they are less reactive when compared to potassium, sodium and calcium. So we required some energy for the formation of what the respective oxide and with the liberation of hydrogen. So here our main aim is production of hydrogen, whether here hydrogen is produced or not. Yes, exactly. So based on this hydrogen, so here these metals from potassium to lead, these metals produce hydrogen gas like this, hydrogen gas. Then what about this one? These metals, copper, silver, Ag, Au, Pt, these metals will not liberate hydrogen. They will not liberate what a hydrogen. They will not react with water. Why? They are less reactive. So that is why they will form only what better, they react with acids only. But here hydrogen gas is not liberated because they are what a less reactive than hydrogen. So here suppose you take from potassium to you take up to potassium to here calcium. So they react with cold water. Indirectly they react with cold water. From magnesium to lead they react with steam, means steam is passed over. Steam is passed over what these metals. So here they react with cold water only. Suppose here you take, they liberate up to this part, they liberate what a hydrogen gas indirectly I told just now. These metals will not, there is no reaction between water and these metals. So hydrogen gas is not liberated here. So that is very very important. Then next one here from, so here if you will go through this, here potassium, sodium, you take calcium, lithium, they react with water. Very, very important. And here up to this part, potassium, sodium, lithium, calcium, magnesium, aluminum, zinc, iron, tin, lead, they react with acids. They react with water. These react with water. These also react with what acids. Then what about this one? Here, if you will take from potassium to water, silver, they react with oxygen. Very, very important. They react with oxygen. Then here, these metals are very reactive. These metals are, the reactivity is very, very low. So, if you will go through this, if you will take from potassium, here, potassium to zinc, if you will take like this, potassium to zinc, what happened? Oxides, suppose to form the respective oxides like this potassium oxide or you take sodium oxides, oxides are not reduced to metal. They are not reduced to what you call metals. It is not possible. Means from potassium to, that is potassium, sodium, calcium, magnesium, water, aluminium, then zinc, up to zinc. So the respective oxides are not reduced to metals by hydrogen. If you will take from iron, so next slab, that is iron. Iron to copper. If you will take iron to copper, that is iron, tin, lead and copper, up to copper, what happened? The respective oxides. Suppose you take ferric oxide is formed, whatever it may be, Fe2O3. Ferric oxide is formed. So at the time these oxides, reduced to metal by hydrogen. It can regenerate so to form what? Iron, like tin. So to form the respective oxides, again here what happened? They form the respective metals. What are they? They are iron, tin, what? Lead and copper. These metal to form the respective oxides. Then next slab, that is what? Ag, Hg. Hg is missing. What you call here? Hg, that is mercury is also here. Mercury, then Ag, Au and Pt. So these oxides, you take suppose HgO. These oxides, they decompose, the respective oxide, they decompose to form by heating, it forms the respective metals. Indirectly, not directly, these metals, it can form, these metallic oxides form the respective metals. So these HgO metals, they also what you call, they regenerate to form HgO by decomposition. So like this, these series are very important. So you have to go through this reactivity series of the metals. They are very important. What are they? Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead. So the metals liberate hydrogen. So remaining one, copper, Hg, Ag, Au, Pt. These metals does not liberate hydrogen, but less than hydrogen. They react with acids. So like that, this is known as reactivity series. So please go through that, and please like, share and subscribe to my channel. I am Dr. JMR, JMR Chemistry. Thank you.